Good morning everyone. I am Tanushri Dadai from Civil Engineering branch, and today I am going to teach you your Theory 2 paper, which name is Structural Design 2. So in the last class we discussed about welding connection and what are the types of welding connection, its advantages and disadvantages, and with some specifications also. And today we will discuss about the design procedure of welding connection, and we will do some numericals regarding welding connection. Okay. So in case of welding connections, there are three kinds of problem. You can see there are three types of cases according to which you have to solve the numericals and find out the design strength of the welding. So first of all, we will go for the case 1, which is on the basis of when the strength of the weld is equal to strength of the small plate. Okay, that means whenever you connect two plates by the help of welding connection, then your strength of the smaller plate will be equal to the strength of the weld of the total joint. Okay. In that case, how you will calculate the strength of the weld and how you will find out the effective length, size of the weld. So let's see the step 1. First of all, whenever a question given, to find out the strength of the weld connection and its effective length and also the size of the weld, then you have to write in your first step is data given. Whatever may be the data given in the question, you have to write that. And also, you have to take some assumptions also. So, in case of step 1, you have to write the value of Fy, Fu and gamma MW. So, if in the question the grade of the steel is not given, you have to assume Fe410 grade of steel, for which your Fu, that means ultimate strength of the steel, is 410 Newton per mm square, and Fy, that means yield strength of the steel, is 250 Newton per mm square. Then gamma MW is the partial safety factor for welding connections, which have two values. One is 1.25 and one is 1.5. So whenever your soft welding is provided, then you can take the value of 1.25, and whenever the field weld is provided, then you can take the value of 1.5. Okay. If in the question the type of welding is not given, like soft and field, you have to assume that the welding is in soft welding. So you have to take 1.25 in that case. Then comes to your step 2, in which you have to calculate the strength of small plate. So here it is symbolized as TDG, or simply you can take the value of P also. So TDG equal to Fy Ag divided by gamma M0. So Fy, you know the value of yield strength of the steel, and Ag is the gross area of the small plate, that is B into T, that means width into thickness, and gamma M0 you know that is partial safety factor for plate sections, which is a constant 1.10. The next step is step 3, in which you have to calculate the design strength of the weld. the formula of design strength of the weld is Fw equal to Lw Te Fu divided by root 3 gamma mw. Here your Lw is the effective length of the welding. That means the length of the welding which is provided in the plate to merge the two plates into a one section. Okay, the portion the welding is provided, that portion you can take as effective length of the welding. Okay, the next is your Te. Te means effective throat thickness, which you can calculate by K into S. So here S is the size of the weld and K is a constant, which I told in the previous class also. According to the angle provided in case of welding, you can take the value of K. In normal case, in general case, we will take the value of K as 0.7. That means if the angle of the fusion phase of the welding lies between 60 to 90, then you can take the value of K as 0.7. So in normal case, you can put the value of K as 0.7, and to calculate the size of weld, you can check out the table number 22 in the code book, in which you can find out the minimum size of the weld and another maximum size of the weld. And then you have to provide the size of the weld which lies in between minimum size and maximum size of the weld. So in case of minimum size of the weld, you have to consider the thickness of the thicker plate, and according to the value of thickness of the thicker plate, you can find out the value of minimum size of the weld in table number 22. Okay. Then the maximum size of the weld, it is depend on the thickness of the thinner plate. That means the two plate to which you have to provide the welding, from the two plate, whichever is the thinner thickness, you can take that value and deduct 1.5 from the thickness. Then whatever the amount you got, that is your maximum value of the size of the weld. Then you have to provide the size of the weld always nearer to the maximum size of the weld. Okay. Then you put the all value here and find out the design strength of the weld. But if in the question it is asked to find out the effective length, then what you will do? Then we will go for the question in which you can understand how you will calculate if the length of the effective length of the welding is asked in the question. So here is a problem. Your question is asked as a plate 125 into 12 mm is to be connected to another plate 150 into 12 mm in a lap joint. Find the required length of side to transmit the pull equal to the full strength of the smaller plate. So here you can see two plates are there, which dimension is 125 into 12 mm and another plate is 150 into 12 mm. That means the 150 into 12 mm is a bigger one plate and 125 into 12 mm is a smaller one plate. So you can see in this diagram, this one is your bigger plate and this one is your smaller plate. Okay, and the thickness of the two plate is same, that is 12 mm. So according to the procedure, we have to write the step 1, which is data given. So here the grade of the steel is not given. So you have to assume that the grade of the steel is Fe410. So according to Fe410, your Fy value is 250 MPa or 250 Newton per mm square, and Fu value is 410 MPa or Newton per mm square. And here also the type of welding, whether it is shop welding or field welding, that is not mentioned here, so that you have to take the gamma MW value as 1.25. So next is your step 2, in which you have to calculate the strength of the smaller plate. So the formula is Fy into Az divided by gamma M0. So Fy value is 250 MPa. Then Ag is the gross area of the small plate, which is B into T. So here your width of the small plate is 125 and thickness of the small plate is 12 mm. So just put the value here. And gamma M0 for the plate section is 1.10, which you can get from the table number 5 in the code book. As a whole, your answer should be 340.909 kilonewton. Then comes to step number 3, in which you have to calculate design strength of the weld. So your formula is Fw equal to Lw into Te into Fu divided by root 3 into gamma Mw. So in this case, Lw is not given. Because it is a fillet kind of welding, your Lw is not given in the question. So we have to calculate the Fw value without Lw value. Okay. So we need to calculate the value of throat thickness and Fu, root 3 and gamma Mw. So here for the size of the weld, we have to take two criteria. One is minimum size of the weld, another is maximum size of the weld. So according to table number 22, you can see the thickness of the plate here given as 12 mm, because here two plates are provided with same types of thickness, so we can take 12 mm as the thickness. And according to the 12, you can see in the table number 22, the value of the minimum size of the weld is given as 5 mm. Okay. So your minimum size of the weld for particular this question should be 5 mm. And then the maximum size of the weld, here you have to take the thinner thickness of the plate. But in case of this question, your thickness is same for the two plates. So you can take the value as 12 minus 1.5, by which you can get the value of maximum size of the weld as 10.5 mm. Then your size of the weld that you can provide should be lies between minimum size of the weld to the maximum size of the weld. And I told you in the procedure, your provision of the size of the weld should be nearer to the maximum size of the weld. So you will take, or we will provide the value of weld as 10 mm, which is nearer to the maximum size of the weld. Okay. And from the table number 21, you can get the value of K, which is a constant, according to the fusion angle phase, that is 0.7. So you can put all this value here, 0.7 into 10 and F410, which is a value of Fu, root 3 and gamma W, which we assume that 1.25. By calculating all these things, you can get the value of Fw as 1325.5